Hello everyone. Today we are discussing a very interesting topic from geometry section of IIT JEE, that is straight lines. So in straight lines I'm going to start from the very basic and then we'll take it to the level of IIT. At the end we'll also see some questions. So in today's lecture we'll be just focusing on basics, basic terminologies. So let's get started. Okay. Straight lines. Now, anyone can think about definition of a straight line. Means what's a straight line? Of course, if you're telling definition of a straight line, you can't use the word line, right? So tell me definition, right? Think. Now, what about definition of collinear points? You all have heard about it, collinear points, right? Actually, you can take the help of the concept of two things here: collinear points and locus. These two concepts can give you the definition of a straight line. Now, straight line starts from first fixing 2 points, any two points you fix, A and B. Now, if I'm finding locus of a point means it's a moving point. There is a point which is moving following some certain rules. We trace the path of that moving point and we call it locus. Now, these two are fixed points. Now, I'm talking about a point which is moving. So, let's say that point is P. Now, if it is moving, I just have to apply a condition on the movement of this moving point P and I'll get the definition of straight lines. So, think. If I move this P in such a way that it remains collinear with the fixed 2 points A and B, I get the answer. Path of a moving point, but it has to move in such a way that everywhere it goes, it has to be collinear with the A and B. So now, right now, I have drawn it over here. Is it collinear with A and B? No, it's not. These 3 points are non-collinear. So let us bring it to a position where these are collinear. Now this, it can be here as well. It can be here as well. It can be here as well. Here as well. So it can move along a path, and if you trace this path, it becomes, this path is known as straight line. I hope it's clear. So, locus of a point such that it remains collinear with the fixed 2 points is a straight line. Isn't it interesting? Now, we have some terminologies. We talk about these straight lines. And very basic to start with is a slope of a line. Now, what is slope of a line? Slope of a line, to start it with, I'm taking a line which is not parallel to either x-axis or y-axis. Okay, so I'm taking a line. It is not parallel to x-axis. It is not parallel to y-axis. That means it will definitely cut both x and y axis, right? Like this, maybe. This line is making an angle with the x-axis. Now you will see, ma'am, there are 4 angles. There are 4 angles. It definitely cuts the x-axis. That can be seen here. But we have angle number 1, angle 2, angle 3. And angle 4. 4 angles. Which one of those angles we are focusing on? We are talking about. Now, answer to this question is, first of all, see, actually there are not 4 angles, there are only 2 angles, 2 different angles. 1 and 3 are exactly same. So, if I'm talking about angle 1, this is exactly angle 3. And if I'm talking about angle 2, this is exactly angle 4. So, let's forget about these two, angle 4 and angle 3. So now our discussion is on whether to choose angle 1 or angle 2. Okay, so for that, you see, there is a term called inclination of a line. Now, this word inclination of a line is the angle of that line with the x-axis. Now, you just have seen that there are 4 angles. Which one is called the inclination? Now, that is special here. That is special. Angle 1, discussion is between angle 1 and angle 2. Which one of them? So, what we do is, we start from x-axis, means a point on x-axis, and you move toward your line, starting from x-axis. Now, you can see that, you can say, ma'am, we can take over here also. No, from positive side of x-axis, right? Positive side of x-axis means this side. Now, you take this anti-clockwise. Your angle must go anti-clockwise. If you start from here, your angle will go clockwise, right? So, from positive direction of x, take anti-clockwise direction. That angle is called inclination of a line. So, inclination of this line is this angle 1. Theta, theta is notation for that angle. This theta is your angle 1. Now, this is a very special angle. We will talk about slope just depending upon this. Slope of line depends upon this theta. It is given by tan of theta. Tangent of that angle is given by slope. Easy. Now this is, see, this is tan theta. So I can say that slope of a line is tangent of inclination of line, tan theta. Okay, so slope of a line joining 2 given points. That means from the definition of that slope of a line that we have seen, you must know inclination first of all for a line, and then you can apply tan, and you must know tan of that angle also. So it's a long process, right? Instead, we can actually have one more process here. Now that process is, if you know 2 points on the line, then also it is possible. See, let's say this is our line. This time I don't know what is inclination. Instead I know two points on it. This is capital A, x1 comma y1, and capital B, x2 comma y2. Drop a perpendicular from A at P. This is x1 comma 0. Drop a perpendicular from B on y-axis. This will be 0 comma y2, right? So tell me about, okay, this point is Q. If this point is C, this is O, tell me coordinates of C. Okay, even if coordinates are not required, see, what is length? Length BC. If you drop perpendicular from B on x-axis also, so you will get, this is x2 comma 0. So this length is x1. This very length is x2. What will be this? This is simply x2 minus x1. Similarly, this length would be y2 minus y1, right? From here. In triangle, so what I'm trying to show is that this is a triangle in which this is A, this is B, this is C. This length is x2 minus x1. this length is y2 minus y1, right? And what about this angle? This angle? We don't know what that angle is, so we can't find slope in this in terms of theta. But we know this angle. This is nothing but 180 minus theta. So this also becomes 180 minus theta. Now why this also becomes 180 minus theta? Corresponding angles. See, this line and this line parallel. So these are two corresponding angles. This is 180 minus theta. We can calculate tan 180 minus theta here. Tan 180 minus theta, that is perpendicular upon base. This is okay. There is a small thing. This is y1 minus y2. Okay. This whole length is y1 because of that A point, and then because of this B point, this is y2. So y1 minus y2. Okay. So this one is y1 minus y2. y1 minus y2 over x2 minus x1. Yes. Now this tan 180 minus theta is what? It is minus tan theta. It is y2 minus y1 upon x2 minus x1, which is tan theta is equals to tan theta is equals to, this is 1, this is 2. So y2 minus y1 upon x2 minus x1. This is formula of your slope, tan theta, slope, right? So slope is y2 minus y1 upon x2 minus x1. Difference of your y coordinates and x coordinates, ordinate and abscissa. Have to take the ratio, but do take care of the order. See, this is very important. Sometimes students just make a very silly mistakes here. They write y1 minus y2 and x2 minus x1. No, it won't be like that. If you are writing y2 minus y1, it will be x2 minus x1. If you are writing y1 minus y2, then it will be x1 minus x2. Okay. So this is slope of a line joining 2 points. Slope of a line having given equation. Now this is also very easy. See, ax plus by plus c is equals to 0. This is given. You have to find slope. Again, if I see this, what about these 2 points, A and B? For B point, your y is equals to 0, x will be minus c by a comma 0. Similarly, this would be 0 comma minus c by b. You have 2 points on the line. You can find slope using 2-point form. Right? We just have done that. So slope of this line would be 0 minus c by b. See the pattern. y2 minus y1 upon x2 minus x1. So upon minus c by a minus 0, c by b over minus c by a, this is minus a by b. So it's very easy, minus of coefficient of x divided by coefficient of y, minus coefficient of a divided by coefficient of b. This is your slope of a line whose equation is given to you. Next is this. Which of the following has the slopes 2? Now it's very easy. Just see which of these options are giving you answer as 2, slope as 2. So let's try with the first one. First one is 2x minus y plus 3 equals to 0, and this is exactly giving you 2, answers 2, because slope is given by minus coefficient of coefficient of x divided by coefficient of y. This 2 is the options. Next, which of the following line is parallel to y? Although we'll prove this, but I'm just telling you a small result here. Slope of parallel lines will be equal, and you can see from the very starting here. Yes, m is equal to tan theta. So now if you have a parallel line, see, then of course this angle and this angle would be same, theta and theta would be same. These are parallel lines. It's a transversal. It's a corresponding angles. Corresponding angles of the parallel lines, same. So again, if the angle is same, tan theta will be same, slope will be same. So parallel line have same slope. So this question says which of the following is parallel. So let's find out slope of this line first. Slope would be given by minus, okay, this is minus slope of minus 2x minus y plus 5 is equals to 0, or I can write 2x plus y minus 5 equals to 0. It is minus 2. Which one of them has a slope minus 2? I can see this C option. C option is minus 2x plus y plus 3 is equals to 2. What's the slope? Slope is minus 2. So C option. Lines have same slope means they are parallel. Okay. None of them will have slope 2 except the C option. Find x so that the line passing through 3, 4 and x 5. Okay, so this is a line passes through 3, 4, passes through 3, 4, x, 5, makes an angle 135 with the positive direction of x-axis. Okay, so let us take this like this, maybe, right? It seems like it will make a angle 130. So it's a line making an angle 135 degree with the positive x-axis passing through 2 points 3, 4, x, 5. So you have theta also, you have 2 points also. You can find slope using two methods here, but of course slope we are calculating for one line, single line, so slopes will be same. So that means tan of 135 degree is equals to 5 minus 4, 1 divided by x minus 3, 135, that is minus 1 equals to 1 upon x minus 3, 3 minus x equals to 1 and x equals to, that's your answer, because slope given by formula tan theta and that y2 minus y1 upon x2 minus x1, they'll be same, that's why. Next, angle between two lines. This is also very easy. You can find out angle between two lines if, see, so let's find out angle between two lines. This is first and this is your second. Okay, so we are calculating this angle theta. Let's say this line here L1 has inclination theta 1 and this line L2 has inclination theta 2. Right? Now, okay, so how we can start here is we already know relation between this theta 1 and theta 2. Exterior angle sum property, theta 2 is equals to theta plus theta 1. Apply tan both sides. Tan theta 2 equals to tan of theta plus theta 1. This is tan. Okay. Take theta over here and theta 2 minus theta 1. Then it will be, we can directly find out. See, we want to find theta, right? So I'm calculating tan theta here. So hence I'll get theta. So tan theta equals to tan of this. Tan theta is equals to tan A minus B. Formula tan A minus tan B divided by 1 plus tan A tan B. right? And what is this? These are slope. So I can write tan theta is given by, in terms of slope of basically those two lines, m2 minus m1 upon 1 plus m1 m2. m1 m2. So this is one formula, but you see angles between these two lines, there are basically 4 angles. What about this angle? Let's say over here, let's say this is acute angle. So this is 180 minus theta. Right? Maybe this is 60, so it will be 120. What about tan of 180 minus theta? If this formula is giving me angle, so what about this angle? What about this angle? Tan of 180 minus theta is also given by m2 minus m1 upon 1 plus m1 m2. This is minus tan theta is equals to m2 minus m1 upon 1 plus m1 m2. Tan theta is equals to m1 minus m2 divided by, or we can say minus of m2 minus m1 upon 1 plus m1 m2. So you see, to cover both of the cases, to cover the case of acute angle and obtuse angle, both of them, I need to cover these two cases. So formula is given by tan theta equals to modulus of m2 minus m1 divided by 1 plus m1 m2, where positive, if you want to make it positive, if you want to solve it for positive, you will get acute angle between two lines. If you are removing modulus and you are putting a minus sign and then you are calculating theta, that will be obtuse angle. So from here, these two formula comes, tan theta equals to m2 minus m1 divided by 1 plus m1 m2, right? From here you can see the concept of parallel lines and perpendicular lines as well. If they are parallel lines, so what's the angle between two lines? So I'll go by that formula, tan theta for parallel lines. Tan 0 is equals to m2 minus m1 divided by 1 plus m1 m2. This is 0. A fraction is equals to 0 if and only if numerator is 0. So numerator is 0 means m2 minus m1 is 0. That means m2 equals to m1. That's why we say that if two lines are parallel, slopes are same. Perpendicular lines, that means tan 90 degree equals to m2 minus m1 upon 1 plus m1 m2. This is infinity. This is 1 by 0, not defined. It is not defined means denominator is 0. When do we say a fraction is not defined? 1 by 0, 2 by 0, these are not defined. So that means denominator is not defined, denominator is 0, which means m1 1 plus m1 m2 is 0, which means m1 m2 is minus 1. These two are conditions for line to be parallel and perpendicular. So this was it for today's session. We'll continue this discussion in the next class, right? Thank you so much.